1927, he embarked on a voyage of discovery into the structural patterns of the universe. A series of inventions charted his course. The Dymaxion house, suspended from a central mast. Dymaxion automobile, streamlined, rear-engined, three-wheeled, it could park in its own space. A new system of map projection, the first patented in centuries, with least visible distortion. Energetic and synergetic geometry led to the geodesic domes, enclosing the most volume with the least surface of whatever materials: wood, aluminum, the basic unit of the Ford Rotunda, a strut 3 feet long, weighing 5 ounces, 19,680 of them make up the 93-foot clear-span dome. Polyester fiberglass, the radomes of the dew line on the Arctic perimeter, built outside in or inside out. Hemisphere, quarter-sphere, full sphere, and air deliverable. His goal, to learn how nature works in order to make humanity a comprehensive success in universe, in outer space, as on Spaceship Earth.
My boyhood was all the summer times of it was spent here in Penobscot Bay, and so that this is the route this way going along here now. So I'm rowing here, which I went off to get the mail every day, 2 miles away over Eagle Island or Butter Island, and return. So the very essence of my life now has become one of thinking and using your intuition. And so my boat, which I imagine will be the last boat I'll ever buy, I hope it's the best boat in the world, and I gave it the name Intuition. After being really a key of thinking. And this whole dealing with nature in powerful, completely liquid manner called for constant alertness and constant feeling of nature. This is the environment of not only thinking but quick thinking. It had to be the right thinking. So you learn that you got to make very, very quick decisions, and it's all over. Nature takes you to the bottom awful fast. Intuition is that contact with our subconscious, between our conscious and our subconscious. There is a twilight zone. So that subconscious that suddenly tells you, listen, there's something very important to be thought about. Intuition is continually opening the doors of thought. Truth that you suddenly glimpse must be secured, that you don't lose that. It doesn't become just a fleeting dream. It can be turned into a reality for all humanity. The great scientists who have made great discoveries, the very most important single factor in their great discovery was always intuition. So the great scientists are the ones who then have the second intuition, the third intuition, the fourth intuition about how you secure that extraordinary glimpse of the truth. I love the sound of the oars. It goes on and on. Absolutely second nature to me, the oars. And so I can keep on thinking that, realizing that I'm rowing any more than I'm breathing. Rowing becomes just as normal to me as breathing. There are several concepts which I think are not clearly and popularly understood, which must be considered in order to be able to understand the great complexity of life and to understand what the universe is doing. The first word is synergy, and the word synergy means behavior of whole systems unpredicted by behavior of any of the parts or any sub-assemblies of the parts. The chemistry of toenail does not in any way predict human being. Synergy is associated behavior of the whole, great complexes, all the way to complex universe itself. I find that in the physical universe, since we've discovered that there is speed of light, then Einstein said, and so did Max Planck and a few other very extraordinary thinking men, if then it takes 8 minutes for the light to get to us from the sun, and takes 2.5 years for the light to get to us from the next nearest star, and this star I'm looking over here, the light is just reaching me from a show taking place 300,000 years ago. So I'm seeing a live show taking place 300,000 years ago. There's another one, hasn't been there for a million years, that star. So they said the universe is not an instantaneous aggregate. It is not then a static instant system. A universe must be thought of as an aggregate of non-simultaneous and only partially overlapping events, where everything is continually transforming. The universe is omnidynamic, is continually transforming at different kinds of rates. A scientific generalization is a pattern which has been discovered to hold absolutely true going through every case. There's no exceptions. As for instance, I'll give you a typical one. We have a man going through the forest, and he's climbing over trees, old fallen wind-blown trees, and he's climbing over one when suddenly the one he's on, he feels it sinking rather slowly, and he retreats a little and it doesn't sink, and it goes back, sinks, and turns around to see what's going on. He's lying over the top of another tree, and the other end of his tree he's standing on is under a very great big tree, and he suddenly sees that great big one lifting, and he goes over then and tries to lift that big tree with his muscle, and he finally can't budge it. So he thinks the tree he has over here, which is lifting it, is a magic tree, and he drags it home. And he keeps it there, and all the family and tribe worship it for 1,000 years, and suddenly somebody discovers that any tree will do. That's what we call then the principle of leverage. That's a generalized principle. And I'll just show you. I just take this little very light board, and I'm pretty lightweight. This big log has been lying here on this beach probably for 10 or 20 years, hasn't been moved at all. So I'll just see what I can do with it. There goes the big tree lifting. Very much more than my weight. So I'm balancing this where a man then demonstrates what he calls advantage. This is the beginning of the very word advantage. All around us are these generalized principles. There's a generalized principle of tension and compression. When you pull on a piece of rope like that, it gets tauter and tauter. It means it contracts its girth, so it goes in compression 90 degrees to my tensing. When I load a compression member from above here, its girth gets bigger, so it goes into tension at 90 degrees to the compressing. These are typical of the way in which we find these generalized principles right here on Bear Island. Things like this going on, being employed by man, because just right over here on the other side of the eating house here, we're using a tension and compression in a very big way. Look at boats. The compression mass, the tension stays, the tension halyards, the tension sails. Here we get a beautiful differentiation of tasks, the tension versus the compression. All around you, it looks kind of tumultuous and jumbled up. You begin to discover order is always operating. I begin to look at all these rocks and it doesn't look like anything. And then I begin to pick them up. And I pick up any rock and I find it has a beautiful face here, and then another beautiful face, another beautiful face. These are not carelessly done. And you begin to study those rocks a little more and you find face, face, face. Nature doing things in very logical, clean-cut ways, and begin to study those even more. I find she's using beautiful geometry. This always finally gets down to the simplest geometry you can get down to. You can't have a geometrical form of less than 4 faces. So it's 1, 2, 3, 4. It's what we call the tetrahedrons. Then sometimes after it gets to be a beautiful tetrahedron, then the ends get knocked off it. So this once was a tetrahedron, then they sheared off here a little more, cut off the point of that tetrahedron. Nature's operating always under beautiful rules, and if you just go over your experiences, more and more of your experiences, suddenly you find those generalized patterns that are operating there that can be employed subjectively to give you great advantage. All our experience resolves into memory patterns and the what I call conceptuality, and everything we think about as conceptual reality. I find that all patterns can be resolved into 2 fundamentals. It seems very extraordinary, but it's so. One is called angle and the other is frequency. Frequency is like your heartbeat, or between drops of rain, or any kind of a repetitious pattern. That's called a frequency. How many frequencies? Some get the frequency at which the hand of the clock goes around and makes the hour. So I find that this angle and frequency then, for instance, has to be referred to one basic axis. We have to take any 2 points in our experience, and we draw a line between them, makes an axis. And in respect to that axis, we can say, I go out at this angle for so many frequencies. If I go out at this angle for so many minutes, then I go change my angle, and I change it and go this way for so many frequencies, and go that way. This way I could describe anything, make any kind of a sculpture. Find all design in the universe simply gets down to, breaks down into angle and frequency. I also discovered that the kind of ways in which man was measuring tend to be much more complicated than what apparently is what nature is doing. As, for instance, I find that man teaches his children about measurement and the integration of arithmetic and form and the form of geometry. And you start off with a plane, and you start off with a line, a pair of lines parallel to each other, and then at 90 degrees to that, another pair parallel, making something called a square. But I find that that's all very well if you could really live in a plane. Nobody can live in a plane. Nobody can squash their body into a plane. That's not the way nature is. She's not in a plane. She's omnidirectional. So when I really look at a square, the way in omni-nature, just taking the 4 sides, I find it's very unstable. It doesn't want to stay square at all. It can only be square if you fasten it into that plane and then really guarantee this thing. But what would be, then you'd have something in that plane that was holding it. So just in its own right, it doesn't have any what I call any pattern integrity. It's just no good. I'd like to find something that is good, something is reliable. If I put more sides in here, it just gets more and more flexible. But if I take away one side, like this, then suddenly, wow, these angles are all, here's our friend angle, this is an angle, and here's a frequency. How long you go in this direction. But now I just go one direction, 2 directions, 3 directions, and I come back in myself like that, and suddenly it's very stable. It doesn't do anything, it doesn't get all flexible the way it's been in the square. We find that here's an angle, and we want to make that angle stable. So this one member stabilize that angle, and this member stabilize that angle, this member stabilize. So this is what we call triangle, 3 angles. And the triangle with the 3 angles is the only stable structure. When you're building a house, the way men try to build houses today, they put posts in the ground, so forth like that. And here is a cube, which most children are brought up with. See how completely no good at all. The only way you can make that stable is then to put some kind of a triangle in each of those places. So when you put up a piece of wood, then you have to put in 3 nails in, so it's not going to do something like this. Otherwise, it's hinge. So I've got to find a way of really getting stability. I'd like to be able to make what I call a basic structure, and I'd like to make it into a system where I have an insideness and an outsideness. This doesn't have an insideness and outsideness. The characteristic of all systems dividing universe inside and out. On the outside, they're convex, and the inside we call concave. Beautiful concavity, convexity. Inasmuch as it's found that the triangle is the only structure, and we found that we could make a structural system that subdivide the universe inside and outsideness, and the simplest one you could get was the tetrahedron, because this does not have an insideness and outsideness. I can't get something that has insideness and outsideness unless I have one more point, and that gives me then the tetrahedron. Tetra means four in Greek, so 1, 2, 3, four-sided figure. Simply say to you, anything and everything that you have ever experienced, that you say, I remember. You remember it because of the pattern. Remember it because of the shape of Scrag. Remember that tree because the way the branches are out like that. I simply tell you that everything is rememberable that makes the pattern so you can remember it is because it has some structure that kept it in that shape. In order to be able to hold a shape, we find only a triangle can give you a shape. Therefore, the basis of everything that you remember and experience is all triangles. All of our experience involves energy. All physical universe involves it. And we have then, these energies are operating in various directions. And so a vector represents an energy action in a specific direction. And the energy, there's some quantity of the energy there as mass, and that energy action is going in some direction. So it has a velocity relative to our other experiences. So we then take the mass and multiply it times velocity, and that makes the length of the line of a vector. It doesn't go to infinity at all. It's absolutely discrete. And it's going in a specific direction in relation to our other experiences. So it's angularly describable. So vectors have specific angular direction and specific length. So we find then that the engineer's concept of action and reaction had to be modified by paying attention to the fact that there is a speed of light and there is a lag between the action, reaction, and the resultant. So you jump off of one boat, and it takes a little time before you hit the other boat, and you then push the boat that you jumped off from, and you push the boat that you land on, so there's an action, reaction, resultant. And that is true of every experience, every event in the universe. Every event is that. Now, remember then, here's the action right in my hands. It is a vector, and here's the reaction, and here's the resultant. Here's a proton, here is its electron, here is its antineutrino. Here is then the neutron and its positron and its neutrino. So we have each of those as a half quantum, one half consisting of actual vectors. This is the way the physicist would express himself. Now I'm going to show you that these two can come together. They could by themselves come together and form a beautiful thing, a triangle like that. But I can have these two of them come together, these, what we call them two triangles we wanted, and I'm going to have always the positive end will always come in, that is, open end will always come into a closed end where there's another end joining. I might call this male, call that female. Come the male and the female. I'll always have these two join as male to female. In other words, there's a constant way of joining. No special condition comes up. So here's a male, it must come to female. So here's male coming to female. Here's another male, must find female. Here's female. Now one male left, I must find one female left. So suddenly then our two events have come together. Made our friend tetrahedron. We'd like to find its relationship to the other basic structural systems. We have then, for instance, the octahedron. Now we find that it has the same length vector. So, however, here 4 equilateral triangles instead. There are 8 equilateral triangles. There are twice as many triangles as there are in this system. We had one more basic structural system in the universe. That was the icosahedron. Icosa with this 20. Icosa means Greek for 20, and here's the icosahedron. There are only 3 basic structural systems in the universe, so this is the one that gives me the most volume with the least structure. This is the one that gives me the sharpest, the greatest strength, because these 3 legs, like any tripod, are much more vigorous in their support. As they begin to flatten out like that, like your own legs spreading out, get weaker and weaker. So here the legs are out very flat, and it is not anywhere nearly as strong But it still is strong because it is triangle, our basic structure. So this is the one that gives me most volume, and I can fortify any one of those by putting a little local tetrahedron there to give it the greatest strength. That's the reason I made my geodesic structure that way. I'm going to take out of the icosahedron one unit of one quantum, as I take away 6 vectors from the 30. There are 30 edges altogether, and so I'm going to take out of here just 6. Now I'll take out, for instance, this one right here. So I took out 3 out of the northern hemisphere, so I turn it upside down and take 3 out of the southern hemisphere. So I will have then, I'll take out this one here. One out of this hemisphere. Now I'll take this one out. And I'll take out this one. I got my 6. Now, what do I have left here? It sort of seems to be very strange kind of a character, but it's what we call a vector equilibrium. You see, where those diamonds were, as they came out, they were diamonds. But I could straighten it out, so each diamond becomes now a square. So now I see 8 triangles, one top and one bottom. You can count them around here now. 1, 2, 3, 4, 5, 6, 7, 8. 8 triangles and 6 squares. 1, 2, 3 squares in the northern hemisphere. 1, 2, 3 squares in the southern hemisphere. So you have 6 squares and 8 triangles. This we call the vector equilibrium. I'm going to move this top triangle, which is in my hands, towards the triangle on the table. The triangle on the table is stuck to the table. It won't rotate. I'm not going to rotate the top triangle. It simply must move. This vertex here must stay right over the mid-edge of the triangle there. Watch now as this goes down. Going down, down, down. Now it's the icosahedron. Now you can see where it goes from vector equilibrium to into each of the triangles can't distort because they're structures. The squares are not structures, so they can distort. So each one of the 6 squares becomes a diamond. Now at this point I could put this vector right across here. And I could put it back here. That's all it was when I took the 6 out. But this goes on beyond there now. It goes down, down like this. And that triangle is still approaching it. Now it becomes the octahedron. Now what's happened is that this whole thing is contracted symmetrically. I purposely just moved one face towards the other, which you'd think it would squash it. But didn't squash it. All 8 vertices moved right in towards common center at the same rate. Therefore, it simply contracts absolutely symmetrically. Anyway, it's now contracted symmetrically in this manner, and we've never had any engineering that found any buildings like that. When you load, snow load, you think it's going to squash it. But it doesn't do so. Loads on these structures simply make them contract symmetrically. That's the same thing this is the icosahedron. When I load a geodesic dome at any point, the whole system contracts symmetrically and continually resists. That's why it's fantastically strong compared to any other structures men have ever used. This is nature's own basic structure. Now, I'll then show you something else. Supposing then I would open it like this and I would pull on the equator. If I were to rotate the equator towards me, it would force it to contract. Now the North Pole gets twisted, gets into that axis, it rotates like that, plunges through like this, and suddenly this has become the tetrahedron. Now we've gone all the way from the vector equilibrium through the icosahedron into the octahedron, now to the tetrahedron. So our vector equilibrium permits all these complete transformations. Sometimes people call this a jitterbug. If this were revolving in space, they were instead of the 12 vertexes, you see there are 12 stars in a little galaxy like this holding together, and there was another great enormous star here. Its mass attraction will pull on this thing and force this equator to go around like that. This is exactly what's going on in the spiral nebula. And within the vector equilibrium came all these parts. This is sort of the great permitted universe of maximum conceptuality, which then becomes into one of these positive and negative sets of structural capabilities, which gives all of our experience. we've come to a concept of totality and unity. We've explored fundamentals of structure, fundamentals of the universe, way in which things would come apart or way they go together, reassociate, way they'll transform. Literature does, as we said, have expression, generalization, covering too much territory too thinly. Science, not at all. Science has something called generalization, which means finding a pattern which holds true in every case. We've examined those generalized principles together. So now I say that when you want to develop a comprehensive strategy, all you have to do is to learn those generalized principles, extract these principles from all the special cases. And there are only very few generalized principles operating in the universe. And because they hold true in every case, if you learn your generalized principles, you're going to recognize them in every special case experience. So there are only possibly a couple of hundred generalized principles operating in the whole universe. And those are the things you go after, and that's what I'm trying to give you here. So I find then with having those generalized principles, we can come then to a very great understanding of how to handle education. Its own education is really of the self. People say to me, I wonder what it would be like to be on a spaceship. And I say to you, you don't really realize what you're doing. Because everybody is an astronaut. You all live aboard a beautiful little spaceship called Earth, and this very only tiny little thing, 8,000-mile diameter ball. So let's take a good look at our little spaceship Earth, just to see how she is provisioned to take care of millions and millions of people for billions of years as she speeds off along all by herself. How is she designed to work?